A standard deck of 52 playing cards is a fixture of everyday life. They sit in junk drawers and on coffee tables, appearing so frequently that we rarely give their physical structure a second thought. But consider the outcome of a single, thorough shuffle. What is the likelihood that the specific sequence you just created has ever appeared before in human history? Mathematically, the probability of that exact arrangement occurring twice is essentially zero. Every time you mix these cards, you generate a sequence that is entirely unique. No one before you has ever held it, and it is statistically certain that no one ever will again. This everyday interaction with a stack of paper creates a massive statistical anomaly, one that requires a look at the underlying math to truly believe. We struggle to grasp this because our brains categorize a deck as a small, manageable stack of 52 individual items. Our intuition tells us that a small object should have a limited number of variations.
However, shuffling is not a process of moving isolated objects from one point to another. It is a compounding series of choices. Shuffling works by multiplying every available position in the deck by the next available position. Viewing the deck as a linear stack of paper ignores this exponential scale. When we look closer, we find the complexity is hidden in the way these choices multiply. We can see this logic using a simplified model of 3 card positions. For the first slot, we choose from 3 cards. Once occupied, 2 cards remain for the second position. The final slot takes the last card. This creates exactly 6 unique arrangements. This 3 times 2 times 1 calculation is the same logic we apply to the full 52 card deck. To find the total combinations for a full deck, we simply scale that multiplication up to the macro level. 52 options for the first spot, 51 for the second, and 50 for the third, continuing down to the final card. The result of that calculation is roughly 8.07 times 10 to the power of 67. This is a number 68 digits long. It is a scale of magnitude that sits far beyond standard human experience or comprehension. At this scale, a common household object enters a realm of mathematical impossibility. Abstract numbers are difficult to visualize, but we can measure the weight of this calculation by looking at the history of the universe itself. Imagine an experiment where you perform one unique shuffle every single second, 24 hours a day, without ever stopping. If you had started this process at the exact moment of the Big Bang, billions of years ago, and continued until this very second, you would still be at essentially 0% completion. This intersection where objective math meets the unbelievable is what we call factorial madness. Every time you finish a shuffle, you are holding a sequence of cards that is unique to the history of the cosmos.